This is problem 9 from section 2.2. It has 3 parts. It says part A, find the leading term of the polynomial. And we see that we have these polynomial p of x down here. Well, leading terms are the terms with the highest exponent. There's something called standard form for polynomials. And that basically says to list your exponents from the highest exponent to the lowest from left to right. So we see our highest exponent is x to the 7th, and we have to take the coefficient with it, which is a positive 1. So we have x to the 7th. Now the next in line would be negative 8 times x to the 6th. And then the next in line would be plus 2x. This is standard form for p of x. Once you have it in standard form, the leading term of the polynomial for part A is x to the 7th. And it's important to be able to identify the leading term because when it's out of order, like p of x is, that leading term is important when we are working with rational functions and identifying horizontal asymptotes because we want to compare highest exponent terms, and if they match, we take the ratio of their lead coefficients to find the location of the horizontal asymptote. Part B says the limit as x approaches infinity. Well, now that we know that this is an odd degree polynomial and it has a positive lead coefficient, we can use y equals x, or the graph of y equals x, to understand the end behavior of the graph. And y equals x goes to positive infinity on the y-axis as x goes to positive infinity. And y equals x goes to negative infinity on the y-axis as x goes to negative infinity. So part B, the limit as x approaches positive infinity, the answer is positive infinity. Because it's an odd degree function, it will mimic y equals x. If it were an even degree function, then we would use y equals x squared as our function to compare it to for end behavior. And when we say end behavior, that is as x goes to positive or negative infinity, because those are the ends that we would be analyzing the graph at. So we can now say part B is positive infinity and part C is negative infinity. Question number 12 is a limit question with the difference quotient, and we can evaluate this. Here we have our f of x, which is x squared plus 7, and the first thing we want to do is put 4 plus h in place of x. So we have f of 4 plus h is equal to 4 plus h in parentheses squared plus 7. And basically all we did was replace any x with 4 plus h. Now we can FOIL this. We get 16 plus 8h plus h squared plus 7. And now we can combine like terms, and we can say that f of 4 plus h is 23 plus 8h plus h squared. Now we would like to subtract f of 4 from that. F of 4 is equal to 4 squared plus 7, which is 23. So if we go back to our limit, as h approaches 0, we're going to replace f of 4 plus h minus f of 4 with our algebra that we've simplified here. And we see we get 23 plus 8h plus h squared minus 23 all over h. And we see the 23's will cancel out. Now we have the limit as h approaches 0 of 8h plus h squared over h. And we see we can factor out an h. And at this point, we see the h's cancel, and we can plug 0 into the last h, and our limit is equal to 8. So here, problem 13 from section 2.2 asks that we find the horizontal and vertical asymptotes for f of x, and we can see our function for f of x here. We have rules for horizontal asymptotes. We want to identify the highest degree term in the numerator and the denominator, and we see we have x to the sixth over x to the fourth. And we learn that if the numerator degree is greater than the denominator degree, there is no horizontal asymptote. And that's what we have here, no horizontal asymptote. The vertical asymptote asks that we find values for x that will cause a 0 in the denominator. So if we take x to the fourth plus 7 and set it equal to 0, x to the fourth equals negative 7, x equals the fourth root of negative 7, and we say, well, we cannot take even roots of negative numbers, so there is no solution here. And since there is no solution, that means we have no vertical asymptotes for this graph. So this is an example of a graph that has no horizontal asymptotes and no vertical asymptotes. So this is the end of this video. Practice the concepts we've done in here, pause it, take notes, and then go back to the textbook and do similar problems.